So this question has come up a couple of times from you. Find an equation of the line that is tangent to the graph of f and parallel to the given line. So we have here two lines. This is the target line right here, the quadratic. So, it'll look like that. And the linear line, which we can rewrite. So I'll rewrite it as 4x plus 9 equals to y, or better, y equals 4x plus 9. That's your standard linear line that has a slope of 4, right? And intercept of 9. So 9, slope of 4, fairly steep. It's going to look something like that. So those are kind of just little things. And so what you're talking about is you want the line parallel to this line but tangent to this one. So you're looking for something with the same slope of 4, and tangent to it. So basically you have a tangent line and you want to meet it so it actually intersects the line you have. Visually, let's look at it on a better graph. So we've got, what was it? 2x squared, so 2x squared. And then we've got y is equal to 4x plus 9. So obviously, that's not the tangent line. We want the tangent line going through at that appropriate place. It's probably going to be up here somewhere. So how do we do that? Well, the first thing is to realize is the slope we're going after is 4. So we want the slope 4. That's the slope we want, and we want that to match the slope of the particular line we have. So we know from doing the derivative, for example, that we can find the derivative of this function, and that would be 4x if you did the work for the derivative, right? Once we have that, we can say, well, what is the derivative? When is this derivative going to be equal to 4? So we let the derivative, the f prime of x, equal to 4, and that's equal to 4x. And that's obviously going to occur when x is equal to 1. Just solve it. So at x equals 1, this curve is going to have a slope of 4. Well, that means also that we have a value of the value at the curve. So if I do f of 1, that'll be 2 times 1 squared. That'll be 2. So at the point 1 comma 2 on the curve f of x, I'm going to have the slope of 4. So I did that analytically. That also tells me what my line will be at that point that I could use. It'll be a line with slope 4 and going through the point 1, 2. So I can write that out. Y is equal to mx plus b. Again, I put 2 in for y, 1 in for x, 4 in for m, and I have a b to solve. And that would be 2 minus 4 plus b, or negative 2 for b. So ultimately, I have y equals 4x minus 2. And that should give me the right line. I can check that in Desmos real quick. So I'll add a 1 here. This will be 4x minus 2. And we see at 1 right here, we particularly have, and you can see visually that it's parallel to the line given. So we found the point at which this occurs. And that was an equation of the line that is tangent to the graph of f and parallel to the given line. So that is the goal, the graph that we're looking for. So when you're looking for this kind of question, that's what you're looking for as an answer. Let's take, that's the look of it. And that's what we'll plug into our function.